Hi, this is Lakshmi Kantiwari. In this video, I'm going to teach you about the k nearest neighbors with Python in machine learning. So earlier, if you have not seen my previous video, you can go ahead and visit my channel KGP Talkie. In the KGP Talkie, you will get there. I have already taught about the logistic regression, linear regression, data visualization in pandas, plotly and the cufflinks, seaborn, matplotlib, numpy and the pandas, etc. So in this video, I'll be teaching about the KNN. So initially, I'll start about the theory, and once we start with the theory, then I'll discuss about the curse of dimensionality, how performance of the model decreases once if we start increasing the dimensionality of the data without increasing the data set. Then I'll talk about how you can decide the number of neighbors in the KNN. Then we will start building our classifier in a Python using scikit-learn library. We will be working on a very famous dataset, wine dataset present into the sklearn. And then finally we will be testing our data, our model performance for different set of the k, such as k is equal to the 3, 5 and the 7. And then we will talk about how you can improve the performance of the KNN model by using standardization and the normalization techniques. And then finally I'll talk about how you can do a parameter tuning with the cross validation. And then I'll talk about the theory of the cross validation, and then I'll do the cross validation, and then finally I'll show you how you can select optimum number of nearest neighbor for your data set to get a best result. So let's start without wasting a time, and please do not forget to subscribe this channel and like this video. If you have any doubts, please comment below. Okay, let's start. KNN is very simple, easy to understand, versatile and one of the top most machine learning algorithm. KNN used in the variety of applications such as finance, healthcare, political science, handwriting detection, image recognition and video recognition. In credit card ratings, financial institutes will predict the credit card rating of a customers. In loan disbursement, banking institutes will predict whether the loan is safe or risk. In political science, classifying potential voters in two classes will vote or won't vote, and KNN algorithm used for both classification and regression problems. So the KNN algorithms based on a feature similarity approach. Now let's understand how does the KNN this algorithm work. In KNN, k is the number of the nearest neighbor. Here if you see here, for example, k is equal to the 1. The number of neighbors is the core deciding factor. K is generally an odd number. If the number of classes is 2, when k equal to the 1, then the algorithm is known as a nearest neighbor algorithm. Okay, so this is the simplest case. Suppose P1 is the point for which level needs to predict. Okay, let's suppose that this is the point for which level needs to predict. First you find the one closest point to this P1 and then label the nearest point assigned to the P1. If you see here, this nearest point is this red one, that is the class A, then you will assign this new point as a class A. Okay, perfect. So for finding closest similar points, you find the distance between the points using distance measure such as Euclidean distance, Hamming distance, Manhattan distance and Minkowski distance. KNN has the following basic steps. They calculate first distance, then find the closest neighbors and then vote for the labels. Okay, so you can take this in these 3 steps. Here we have initial data, class A and the class B. Class B is a green point, class A is a red. And then here we have we are going to calculate the distance, and here you see we have a total the nearest neighbor. Let's say suppose that we have a 7 here or a 3. Okay, if we have a 3, then we are going to include this and this. If we have a 7, then we are going to include perhaps these 4 and these 3. and then we will calculate the distance, okay, between these points, and finally the minimum distance. This new point will fall in the class level where the minimum distance occur. Okay, so now let's go ahead and learn what is the curse of dimensionality. KNN performs better with the lower number of features than a large number of features. You can say that when the number of features increases, then it requires more data. Increase in dimensions also leads to the problem of the overfitting, and for some specific point, increase in dimensions, classifier performance increases, but after a certain point, classifier performance start decreasing. That is the case of the overfitting. To avoid overfitting, the needed data will need to grow exponentially as you increase the number of the dimensions. This problem of higher dimensions is known as a curse of dimensionality. To deal with the problem of the curse of dimensionality, you need to perform principal component analysis or a feature reduction techniques before applying any machine learning algorithms. Research has shown that in large dimension, Euclidean distance is not useful anymore. Therefore, you can also prefer other measures such as a cosine similarity, which gets decided less affected by the higher dimensions. Now the question comes, how do you decide that how many neighbors you need while working with the KNN? This is really very tricky questions. You can understand the KNN mechanism by this the figure. When k is equal to the 3, you see this new point will fall into the class B, but when the k is equal to the 7, new point will fall into the class A. Then this is always a very tricky question. What is the optimum set of the neighbors in the KNN? Okay. So the research has shown that the no optimal number of neighbors suits all kind of the data set. So each data set has its own requirements. So in the case of a small number of neighbors, the noise will have a higher influence on the result, and the large number of neighbors make it computationally very expensive. So research has also shown that a small amount of the neighbors are also flexible fit, which will have low bias, but high variance and a large number of neighbors will have a smoother decision boundary, which means a lower variance but higher bias. So how you can work with this one? Okay, so it's always advisable to calculate the mean square error and the performance of the model with the variable number of the nearest neighbor for your the problem data set, and then make a list and then plot that list. And once you make a list and plot versus the neighbors and the performance of your model, then you can optimally choose your number of neighbors. Okay, so I'll be telling you in this lesson how you can choose optimum number of neighbors. So let's go ahead and start building a building a model in a Python using scikit-learn. We are going to use very famous dataset, wine dataset, which is very famous multi-class classification problem. This data is a result of a chemical analysis of wines grown in the same region in Italy using 3 different cultivars. The analysis determines the quantities of 13 constituents found in each of the 3 types of the wines. And here you see here, these are the 13 attributes or 13 the features which we will be using in this data set, and this results into the 3 output. Okay, so that's the 3 output, means the 3 classes, final output classes, and these 3 classes are, is it given here or not? Okay, yeah. So here the 1 to 3, okay, and those classes, let me see if we have here classes. We don't have classes, but anyway, I'll be showing you here once I load this data set. So let's go ahead and work with sklearn. here the sklearn import dataset, and then wine is equal to datasets dot load wine. Okay, perfect. Now here we have wine, and once we have wine, let's go ahead and see what is the keys of this wine, the data set. So this has keys, the data, target names, description, and the feature name. So let's go ahead and get the description here. So this is the description here, although this is very jiggly wiggly. So these are the 13 set of the features which we are talking, and so this is the 3 classes, class 0, class 1, and the class 2. And here this is the target data, and this is the data. Okay, perfect. So the data set comprises 13 features: alcohol, malic acid, ASH, etc., etc. And this data has 3 types of the cultivars classes: class 0, class 1, and the class 2. Here you can build a model to classify the type of the cultivars. So the data set is available in the scikit-learn. You can directly load by just calling here datasets.loadWine. Now let's go ahead and import the necessary libraries. And here we need to import, let's say, the pandas as PD, seaborn as SNS, matplotlib.pyplot as a PLT, numpy as NP. Okay, so let's go ahead and run this, and once we have this, we are going to load the data into X here, and the target we are going to load here into Y. So we have here X, you see here. So the X has 178 rows, and the Y also has 178 rows, 13 columns. That shows that there are 13 features. Perfect. Now let's go ahead and split this data. Okay, so split data to understand model performance. We will be calling train test split, and to do that we need to first import sklearn model selection. From sklearn model selection, import train test split, and then xtrain, and then xtest, then here we have ytrain, and then here we have ytest is equal to the train test split, and there we have xy, and there I have the test size. Okay, so here we have a test size 0.3, and then here we have random state is equal to the 42, and here we have a stratify is equal to y. So here we have got xtrain, xtest, ytrain, ytest. Now let's go ahead and first generate a model for k is equal to the 3. Earlier I told you that we will be testing for different set of the k, and then finally we will decide which number of k will be best suited for our classification. Okay, so now let's go ahead, start with the model generation for k is equal to the 3. And for that we need to first import k neighbors classifier from sklearn, sklearn.neighbors, import k neighbor classifier. Then here we have KNN is equal to the k neighbor classifier. Here we have n neighbors is equal to first 3, and then here we have KNN dot fit x underscore train, and then y underscore train. And once we have KNN.fit, then we are going to get yPredict. yPredict is equal to KNN.predict x_test, right? This says that, yeah. Now let's go ahead and get the metrics for this. And to get the metrics, what we need to do here, we need to import the metrics from sklearn. Import metrics, and then I am going to print here accuracy, and that accuracy is metrics dot accuracy score. In the accuracy score we need to pass here yTest and then yPredict. If you don't know what is the input parameter to accuracy score, you need to press here shift and double tap. You will see here the detailed documentation. So it says that 68.51% accuracy for k is equal to the 3. Now let's go ahead and copy this and build it for k is equal to the 5. In this case, we just need to replace k neighbors is equal to 5 instead of 3. And this says that we have got the accuracy 72.22%. Now let's go ahead and build it for k is equal to the 7. Now here we have got 74.07% accuracy. So as you see here, we are increasing k and we are getting a better accuracy. Okay. So here you have increased the number of neighbors in the model and the accuracy got increased. But this is not necessary for each cases that an increase in the many neighbors increase the accuracy. The training phase of the k nearest neighbors classification is much faster compared to the classification algorithm. So this is the pros as compared to the other classification algorithm. So here we are talking about what is the good in the k nearest neighbor. There is no need to train a model for generalization. So that is why KNN is known as a simple and instance-based learning algorithm. But there are some problems in the k nearest neighbor algorithms. Those problems are the k nearest neighbor classification is slower and costlier in terms of the time and the memory. It requires large memory for storing the entire training dataset for the prediction. KNN requires scaling of the data because the KNN uses the Euclidean distance between the two data points to find the nearest neighbors. That means if you see here our earlier data, okay, so x. So this x is the not scaled version of the data. Okay, so this is the unscaled version of the data. We need to normalize or standardize this data to get a better accuracy. So once we standardize or normalize this data, we will be getting a better accuracy. Since this k nearest neighbor works on the distance based matrix, suppose that if class A have some values into a scale A and the scale is always less than 1, and the class B have a scale B where scale B values in hundreds or the thousands, then definitely the distance between if we calculate the distance between the class B and the class A, the class B distance will be the very skewed. So that's why we need these classes are the features spaced into the same dimension or same scale. So we need to do the data normalization or standardization. So let's go ahead and do the data standardization. sklearn with the sklearn pre-processing, we can do it very easily. So here we have sklearn dot pre-processing, import standard scaler. Then here we have scalar is equal to standard scaler. Oops. Here we have x underscore scaled is equal to scalar dot fit, underscore transform and x. So you see here now we have x scaled, and earlier we had here x. If you compare it, now we have got our x scaled into all 13 features in the same scale. Now the accuracy should increase. Let's go ahead and test our accuracy for k is equal to the 7. Earlier we had 74.07% accuracy. But we need to also get here x train and the y train, and I can just copy it and paste it here. We have here x scaled, y and everything is the same as previously. So let's go ahead and test it. Now we have got our accuracy 96.29%. You see here how much accuracy we have improved just by standardizing our data set. So the data set pre-processing and the data engineering and the feature engineering is a very important part of the machine learning. The model building and the training is just 3 lines of the code, but the data preparations and the pre-processing is very important, and it takes a lot of the effort to do that. Now let's go ahead and do the parameter tuning with the cross validation and try to find out the best fit, the best number of the nearest neighbor for this algorithm. So how it works? Okay, so let's suppose that we have a number of neighbors, so we will be increasing number of neighbors and we will be also calculating the error. Okay, so once we calculate for let's say the 50 neighbors, then we will find out the minimum the error point, and then we will select the number of neighbors for our testing data set. So this is just an example, although we will be doing in our the algorithms the different number of neighbors. So the techniques by which we will be doing this, that is known as a cross validation. Now the question is how it works. So in the cross validation, we divide our data set into the many the subset. So we take one subset for a validation and the rest of subset for the training the data, for training the model. And let's say if we have a 10 cross validation, 10-fold cross validation, in that 10 cross validations, we divide our data set into the 10 part, and we take 1 part for validation and 9 part for a training. And then the next time we take the second part for a training, for the testing or for validation, and the remaining 9 parts, these white color parts, for a training. And similarly it goes for 10 times, and then finally we calculate the mean of the accuracy or other accuracy metrics to find out the performance of our model. Now let's go ahead and implement the cross validation. Okay, so to implement this, we need to first import cross validation score from sklearn model selection. So here we have a model selection, import cross val score. So here we are going to put here first neighbors. Neighbors is equal to, I'm going to create here a list, their list range. I'm going to create between 1 to 50 by 2. CB underscore score is equal to 2 for K in neighbors. KNN is equal to K neighbor classifier, and then here I'm gonna pass here number of neighbors is equal to the K, which will be varying from 1, 3, 5, 7, etc. always odd. And then here I'm gonna create here score in cross validation score, and there if you press shift and double tab, you will get here the parameter input parameters for cross validation and score. So the first I'm gonna pass here estimator, and estimator is the KNN, and then I'm going to pass here X train, and then finally I'm going to pass here Y train. Instead of X train and the Y train, I'm gonna pass here X and the scaled version, and then here I'm gonna pass here Y, and then cross validation is gonna be 10, and then here is scoring is gonna be based on accuracy. Then the CV score is list there. I'm gonna append this score, okay, the mean value of this score. Okay, since for each validation, for each iteration, it will be giving a score, so we need to get the mean of that score. So here I'm gonna put here the mean of that score. Now let's go ahead and calculate this. Okay, so here in the CV scores we have our score. Right, now let's go ahead and print the CV scores. You see here we have a score. Now I am going to plot this score. So let's go ahead and I'll show you how we can plot this score. To plot this score into a graph, we need to write some function. So here we have MSE is equal to 1 minus x for x in CV scores. So in this way it will create a list. Okay, so you see here now this is list which is simply just 1 minus this value. Okay, 1 minus this value, 1 minus this value. Although I think you can do this by sorry, so this is not supported, although I was trying to get that one. No problem. So let's go ahead and write here optimal k. Optimal k is equal to neighbors, and then MSE, then here we have index. Here we are going to calculate a minimum MSE. Okay, so where the minimum MSE occurred, it will get that index. So perhaps this one is the minimum MSE here. Okay, so let's go ahead and print this minimum MSE. So we can just print it. So here the optimal number of k is optimal k, so that is 23 in this case. Okay, now let's go ahead and plot this. So how we can do this? plt.plot and the neighbors, and similarly we are going to plot here with the MSE. Okay, and then here we have a plt dot x label number of k, plt dot y, here we have error. Now let's go ahead and plot this. Even though if we say here the plt dot so, now you see here, so the 23 is showing a minimum error. Okay, so the k is equal to the 23 is the best result for our classification. Now let's go ahead and select k is equal to the 23. Okay, so to do that, what we can do here, so let's go ahead, copy and paste it here, and here the test size I'm gonna select here the 20%, and this I'm gonna select the 23. Okay, So you see here the accuracy is 97%, although if we make it 1, then the accuracy will be 94%. If we make it 3, it's a 98%. So the moreover, for k is equal to the 23, it will be always giving best result. Okay, so that's a great, perfect. So this is all about for this video. Please do not forget to subscribe this channel, and if you have any question, please comment below, and please do not also forget to like this video. Bye bye, have a nice day.